Okay, we're here talking about the science and technology of soft washing. There's a couple fundamental parts of this that you would want to look at. So, part of this is when we look at science and technology, you say, what is the problem? Like, what is the problem that we're trying to solve for? What tool or what technique or what is our proposed solution to that problem? And how do we execute that? Like, how do we do that? So let's talk about what the problem is. When a client calls us and we're going to go clean something and they say, I want my house cleaned, washed, roof washed, what is it they're really saying, right? There's this stuff that I see that I don't want to look at anymore. I want it to look like the house without that stuff on it. Fundamentally, that's what they're saying. So in their mind, it needs to be cleaned. And we look at it and say, it needs to be disinfected, right? Could we go out to the marketplace and go, Superior Soft Wash, we disinfect the outside of homes, call us? Who would call us? Three geeks who understand because they have jobs in chemistry or botany or chemical engineering that know what the hell we're talking about, right? Or they sell fungus for a living, right? There's like four of those people in our market. We wash homes. We can even say we power wash homes. I have commercial clients who still send us contracts that say power wash the buildings. Okay. And I write them back. I send them the signed contract, and then I go, "You used foul language with me in the contract. What? Yeah, you used that power wash word. Oh yeah. I get it. I get it." So, also have a client that calls us soft scrub.
Good.
You know that stuff, clean your bathroom with.
Yeah.
They call it. Hey, Mike, get a price from Soft Scrub to clean, such and such apartment building. Um, anyways, you look at the fundamental problem. What are we solving for? It's an infestation. Write that word down. Really important word you want to use. When you talk with your clients, I'll even say it, the home's dirty, needs to be washed. Really, it's an infestation. It's got mold, mildew, algae, fungus, moss, lichens, bacteria. Okay? I want to write those words down too. You get used to saying those. Mold, mildew, algae, bacteria, fungus, moss, lichens. Mold, mildew, algae, bacteria, fungus, moss, lichens. Lichens is Lichens. Some people call them leeches. I've heard that too. I've never heard them pronounced that way, at least not in scientific circles. I might be mispronouncing it. Maybe it is leeches. I call them lichens. Um, so that's the stuff that grows on the house, the roof, the patio, the deck, the sidewalk, the driveway, the awnings, everything we clean, screen enclosures, you name it, right? That's the stuff that's growing there. So it's living on the home. What's it doing there? Why is it there? What is the function of all that stuff? They are very green and environmentally friendly because they are nature's recyclers. So they should be adored and loved because they recycle. They recycle more than we do because it's their sole purpose of existence is to take something that's not really living or moving or productive and to break it apart into pieces and then put it back into the earth. So if you have a house made of vinyl, brick, whatever, and let's say we left it there for 100,000 years and you take away the wind, so we can't say it was wind erosion, the wind knocked it down eventually, and you just left this stuff grow all over it and you let it rain on it because it needs moisture. And in 100,000 years, you come along and that house would no longer be there. You might find the foundation in the ground, maybe, I don't know, not important to the discussion, but the house itself would be gone. Those little critters would break that stuff apart and it's all gone. It's recycled. It's back in the earth. Break it down into little bits, usable pieces. It's like breaking it on the Lego building down into individual Legos and you get to do something else with it. So that's the purpose of this stuff. So it's going to harm the building eventually if it's left to grow on that surface. Will it harm it in a year or even in our lifespan? You know, we'll get into that. Some surfaces, yes. Some surfaces, I'd argue, like, I don't think you could be hard to notice the damage to a brick building, a brick itself, of mold, mildew, algae, or bacteria. Fungus, moss, and lichens, different story. They're more aggressive. They're sort of more harmful decomposers. But if algae is growing on a brick house, is it really going to make a difference in the brick in 80 years? I don't think we notice it. I don't know. We tend to clean the stuff off, so I guess there's no test study for it. But the point is, that's what they do. It's not dirty. So the nature of the problem that we have is what we call organic. Not organic the way these freaking wackos talk about it today, and everybody thinks they know what they're talking about. This is organic farming. Organic farming is terrible for the environment. What's really good for the environment, I shouldn't say that entirely. The word organic, when it comes to science and chemistry, is not how it's used in marketing today. So organic is meant to say, oh, better for the environment, natural. Okay. Most of the ingredients that have been put into fertilizers and all of that stuff, or 100% of those components, ingredients, are naturally occurring fertilizers. It's just that it's manufactured into a little pellet. Okay. Now we do it a certain way and we get to call it organic. Point is, that organic is not what we're talking about, organic. What we're talking about organic is as in organism, as in life forms, carbon-based life forms. It's living stuff. Okay. Um, so the stuff that we're attacking is alive. It lives. So do we need to wash it or clean it? We need to kill it. We need to disinfect the surface of the materials, the stuff growing on it. So we're not trying to blast it off. We're not trying to scrub it off. We're not trying to irritate it or agitate it off with turbulence or sandpaper or wiping it or using soaps or whatever. A lot of power washing companies advertise, read their websites. You know, SoftWash, we use detergents. And they don't know what the hell they're talking about. They're just grabbing words they read on labels and got told at some conference or the next guy over in a YouTube video. He said it, so it must be true. If it was said, that's a rule. It's a law of the universe. If it's said by 10 different people on YouTube, it's true. Right?
No.
Yeah, it's bullshit. So, what we're cleaning is an organic problem. So, that's the problem. What is our solution to it? Is to clean where we can safely and effectively do this. There's a principle in cleaning called the 3 T's. Write this down. Time, temperature, turbulence. Okay? Time is really simple. That's the amount of time you do the thing. Whether it's scrubbing, if I scrub twice as long, you would expect not necessarily twice the results, but you would expect better results out of twice the scrubbing, right? If I sandpaper something, I would expect better results out of something I did that for twice as long. If I put a chemical on something, a disinfectant, you got a wound and it's infected, and you pour some hydrogen peroxide on it. If you let it sit there for 30 seconds, or you let it sit there for a minute, what do you think gives you the better result? More time generally means better results. Okay, really simple concept. Temperature. This is true. Things that are done at a higher temperature go faster. There's a limiting need for this. If we cleaned with hot water in doing our process, provided the water wasn't too hot to break down and make the chemicals themselves ineffective, or it breaks them apart and changes their chemistry, it would be better. It would go faster. In a practical sense, first, we don't do that. We're not going to take a hot water pressure washer and do that. In a practical sense, when we're working at standard temperatures of about 60 to 90 degrees Fahrenheit, it's irrelevant. You know, it's not going to make that much difference. Where it does make a difference is when we get down into the cooler temperatures in our off seasons. We'll get to that later. We have special little ingredients that we use to add to the mix to make our products work better at lower temperatures. Okay. But a higher temperature in a chemical reaction, by and large, is going to make that chemical reaction go faster. So we're trying to kill stuff, and the stuff that we're trying to kill will die faster at higher temperatures. Even at 90 degrees versus 60 degrees, you would notice a difference. Not substantial, but there would be a difference. Okay. For practical purposes, there's not a need in our type of cleaning to add an extra effort to make the temperature of the water or the solutions hotter than they are at whatever room temperature we work from. Okay. Turbulence. That would be simple things like agitation. In our industry, the number one source of turbulence would be a pressure washer. So now it sounds like I'm talking out of two sides of my mouth. I just said that we can do a better job than a pressure washer because we're not cleaning, we're disinfecting. But yet, when it comes to turbulence, a pressure washer would do a better job than we would do. Okay? This had to do with cleaning. Technically, we are disinfecting. Turbulence is not needed to disinfect something in a practical sense. Okay? Would it be more effective? Arguably, it would be. But is it going to make a difference for our purposes? No. In fact, it's more likely to cause problems. We'll get into these types of lessons later when we start talking about the aging process of materials and oxidation. It can open up a whole can of worms. Stained wood and things like that, painted surfaces. You don't want to agitate those. But back to this whole concept, the proposed solution is to use a minimal amount, and pressure is not going to be needed. So that's not a factor. I don't need a tool that makes pressure. I don't need agitation, and I don't need uh, the temperature factor of an increased temperature for what I'm cleaning. These aren't the only three things that matter in cleaning, obviously. And then there's the time. So when you compare time, remember, more time means same exact process or solution, this chemical or this cleaning solution applied for a minute versus the same exact cleaning solution applied to the same scenario, but for 2 minutes, you would expect a better result out of the 2 minutes. So we want to put the solution on there for us at an optimal point where we know it's done, but then no more time is needed. So we're wasting time when the result has already been achieved. So how do we get more dwell time out of the products, out of the application? We're going to get into that next lesson when we talk about the chemicals that we use. Okay. So the application is to use our agricultural sprayer system to SoftWash. Okay. To apply the solution, make it stick to the surface we're cleaning or disinfecting, and then we rinse it away. Okay. So the problem was an infestation: mold, mildew, algae, fungus, bacteria, moss, lichens. Right. We're trying to get rid of that stuff. The proposed solution is in a SoftWash is to apply a disinfectant. How do we do that? We use an agricultural sprayer system. Right now, the way our trucks are built with the 12-volt system, our application is done at less than 60, less than 60 psi. Your pressure switches are rigged and built. Those pumps are installed with a pressure switch that will not exceed 60 psi. So the way they're set, in fact, right now, the way they come out of the box, it's set even lower than that. We turn them up a little bit. They shut off at around 55. So if you put a pressure gauge against that, you'll see that you can't even exceed about 55 psi. It's enough distance for you to get the three stories. You can hit 3 stories. You can spray about 32, 33 feet with it. Okay. But you can't run any more pressure than that. The rinse pump application that we use currently is a booster pump. Anybody ever live in a house that has a well? Okay. I owned a home that had a well. The pumps that are installed to make that run that well, the pump itself, is what's on your truck. We call them booster pumps because they will enhance the pressure. The pressure that comes out of the house is this much, and the pressure we're going to rinse with is higher. So it boosts the pressure. I don't know. Somebody came up with that term, described it, said it's a booster pump. But it's a well pump. It's really all it is. It's not like a well pump. The guy that buys and installs well pumps would look at our truck and go, "You're using a well pump." And we go, "Yeah, it's like a well pump." No, it's a well pump. It's what I use. We just call them booster pumps. Okay. And that thing's rigged to run at about 110 to 125 psi. Okay. Used to be about 90, but we went with a bigger pump. We used to have 5-gallon pumps, and they run at about 90. These 7-gallon pumps run at about closer to about 120, 125 with the tips that we use. Okay. So you get a little more water for rinsing power, but a little more pressure. Helps with the distance. You know. So the science and technology, that's the whole approach. When you look at a roof, the number one bacteria that grows on your roof, that's a big fancy word. You can write it down if you want. It's impressive to the client. It sounds like you know what you're talking about. It's called Gleocapsa-magma. You'll write it down. Gleo.
You
Gleo.
said Geo?
GleoCapsamagma. Gleocapsamagma. Fancy word for this purplish looking bacteria. It grows well even in the sun, grows better in the shade, grows in the sun too, thankfully. That makes us money. We get rid of it, we give guarantees, it still comes back. That makes us more money, but our cleaning will last longer than others. Um, so you look at back up to the whole thing, whether it's the roof or the house. When the sidewalk's black and we treat it, isn't it amazing how it cleans up? We didn't pressure wash it, did we? It didn't come out. The black didn't go away because you put the booster pump on it. In fact, that'll kind of slow down your progress. If something's already wet with water because the booster pump hit it, even with the pressure, and the stuff doesn't move, you let it dry, you put the solution on it, the black goes away. It's clear again, right? And you rinse it off. It's because it kills it. It's the same stuff that grows on your house and on the roof. Okay? Everything. All the stuff that we're cleaning. We'll get into the chemicals. We're cleaning up some dirtiness, okay, other things too. But the primary component of what the problem is the living stuff. So I think that really concludes the basics of what we're trying to cover right now. So again, to recap, the problem is an organic infestation, living stuff that decomposes materials. The solution is to provide a disinfecting cleaning solution so that we can kill that stuff safely and rinse it away. Okay. And then the tool of choice to do that that's highly effective is our SoftWash agricultural sprayer system. To add on to this, one last thought is we also, there's the spider webs and bugs nests and all that stuff. We'll get into that too when we talk about the different chemicals and the ingredients that we put into the cleaning solution. Makes that work. We have an additive that makes the spider webs and bugs nest break down really well. It's not an organic approach because that's not like a living thing. The web itself and the nest that the bug makes, those little mud daubers and stuff, that's not an organic material, but we have stuff in the ingredients that will make that stuff go away too. Okay. So that concludes this lesson. We'll see you on the next one.